Hello student, welcome back to physics class. And today we'll be starting the new chapter, that is magnetic effect of electric current. Okay, this is the next chapter about which we were talking about regarding class 10 and term 2 examination. Okay, so in this chapter we'll be talking, you can see that it is written here that magnetic effects of electric current. That means that if we are passing electric current through any conductor, then we can see some properties of magnet in that conductor. Okay, so when we see the property of magnet, then there are some physical quantities which are associated with that magnet. Okay, for example, the most important property when we talk about the magnet is the property of magnetic field, which we can relate with magnet. Okay, so for that property, for that physical quantity of magnetic field, first we need to understand that what is magnet. Okay, so here you can see that the definition of magnet is written. Okay, an object which shows the property of attracting small piece of iron towards it, resting in north-south direction when suspended freely. So first property is that for magnet that it should attract any piece of iron which is placed nearby it. And second is that when we subtend that magnet with the help of thread, one can say, so it will orient itself in such a way that it will be pointing towards north and south pole of the earth. Okay, so like that we can consider. This is the bar magnet and it will be pointing in north direction and in south direction if it is suspended with the help of a thread. Okay, it can rotate also and it will adjust itself in such a way that there will be one end which will be toward the north pole and there will be the other end which will be towards the south pole of the earth. Okay, so that's on the basis of that property only we can say that there is one north-seeking pole. North-seeking pole and the other is south-seeking pole. Okay, south-seeking pole. Okay, for that magnet. So now after discussing about that what is magnet, let's talk about the property which the magnet associate. That is the property. That property is known as the property of magnetism. Okay. So what is magnetism? Magnetism is the property of that magnet. But what are the roots for that magnetism? Okay, there is one physical quantity that is known as the magnetic field, and just because of this magnetic field only, it shows the property of magnetism. Okay, so magnetism is the property of that magnet. Okay, by the help of which it has a tendency to attract the iron piece which is kept towards it, and it may orient in north and south direction. Okay, but what is magnetic field which results in magnetism? Okay, so magnetic field is what? It is the space around the magnet. As you can see, it is written. Space around the magnet where the magnetic force is experienced is called magnetic field. Okay, that means there is a region around this magnet in which we place any conductor, then it will get attracts toward that. It will get attracts toward that magnet, and that space around that in which any conductor may experience any force of attraction is known as the magnetic field, that I denoted by m dot f. Okay, and what is magnetism? The property by virtue of which the magnet attracts. Okay, the property by virtue of which the magnet attracts a small piece of iron which is kept nearby it is known as magnetism. Okay, so magnetism is the property which is just because of the presence of magnetic field in magnet. Is it clear? So now let's discuss something more. So after discussing about magnet, after discussing about magnetism and magnetic field, now let's talk about the term magnetic field lines. Okay, so if we define the magnetic field lines, then they are supposed to be a closed curve. Okay, like this. If this is the magnet which has the north seeking end and south seeking end, so it will be what? It will be having originating some lines like this, or one can say the curve like this, which will be joined in from inside of that magnet also. Okay, so like this, the curves are originating from that magnet around the region. Okay, around the magnets. There will be numerous of curves like this. There will be the numerous of the curves which we can observe experimentally around this magnet. Okay, and these closed curves, these are closed curves, are known as magnetic field lines. Okay, are known as magnetic field lines. Okay, so magnetic field lines are what? Closed curve which we can observe in case of magnet. And one thing very important, that how we can relate these magnetic field line with the help of with what magnetic field, that if we want to find out the direction of magnetic field, because magnetic field is a physical quantity and it is a vector quantity and it has direction. So if we want to what? Define the direction of that magnetic field, then we just put a point on any of the curve. Okay, for example, if I am talking about this curve, then I place a point on this curve, and the very important thing is that magnetic field lines originate. It originates from north seeking end of that magnet and ends towards the south seeking end, like that. So similar thing will happen with the other curves also. So from here the magnetic field lines are originating and it is going to the other end. Okay, like this. So if I take any point on that curve, if I take any point on the magnetic field line, one can say, okay, so if I draw the tangent at that point, so this tangent at that point on this curve, on any of the curve, will give the direction of that magnetic field. Okay, so to get the direction of the magnetic field, it is very important that we should understand the picturization of magnetic field lines. Okay, they are the curves which you can see, which originates from the north end and it ends towards the south, and it is closed. Every curve which is passing has a match inside in a straight line, like that. Okay, so now after discussing about all these factors, now let's talk about the property of that magnetic field. That what are the properties of magnetic field lines, one can say. Okay, you can see that there are numerous of curves. So what are the properties of these magnetic field lines? Okay, so first property is that they originate from the north end of the magnet and ends towards the south end of the magnet. Okay, this is the first property. And second property is that if we are talking about this end, if I am talking about this end, that is the north end of this magnet, then what will happen if we come close to that and if we observe it experimentally, then we will observe that the density of these lines which are originating, or the density of these magnetic field lines which are originating, is more. Okay, near the pole the density of the magnetic field lines are more as compared to that point which is far away from that pole. Okay, here you can see that the spacing in between the magnetic field line increases continuously like that. But if we are talking about that point which is very close to any of the pole, so we can say that here the spacing are very less. So one can say that near that there will be the strength of the magnetic field. Okay, these number of the lines which are coming out and going inside determines the strength of the magnetic field. Okay, that how many lines are passing through any area, any cross-sectional area, that determines the strength of that magnetic field. Okay, so here you can see if I'm talking about this area, if I'm talking about any point, then the number of the lines through that point will be what? Or if I'm talking about any area near that, number of the line passing will be more as compared to this region which is far away. So more we go away from that magnet, less will be the strength of that magnetic field, okay, or less will be the force of attraction of that magnet, okay. And another property we can also include is that from this figure we can say that the magnetic field lines are not intersecting one another, okay. You can see that the magnetic field line never intersects each other. So these are small points which can be asked in the examination, okay. So here are few of the properties which I have discussed for magnetic field lines. Now let's talk about the direction of that magnetic field, okay. Now let's talk about the direction of that magnetic field lines. So or magnetic field curve, one can say this can be considered to be in the form of curve in the closed loop. So this totally depends upon the structure of that conductor or the structure of the magnet which is there, which we are having, okay. So if we are having a conductor, let us say if I am having a wire, okay, and through that wire, like this straight wire I am having, and through that wire if I draw I amount of current, let us say, so it will start behaving like a magnet, okay, it will start behaving like a magnet, and that's what we want to talk in this chapter, that magnetic effects of current. Earlier there was no current, so it was what? It has no property of magnetism. But now as we have passed the current, few amounts of current from this wire, conducting wire, so it will start conducting and it will start behaving like a magnet. Now if I place any iron particle near this rod or near this conducting wire which is carrying I amount of current, so that iron particle will be facing some attraction, okay, it will be facing some force on it. And why it is facing some force? Just by the presence of the magnetic effect in this wire, by the passage of current, okay. So there are some rules that how we calculate the direction of magnetic field, okay, how we calculate the direction of magnetic field lines. So one rule which is very important is right hand thumb rule, okay. One rule which is very important to determine the direction is right hand thumb rule. So for any wire which is in a form of straight line like that, we can apply there the right hand thumb rule to calculate the direction of magnetic field, okay. So if we want to calculate the direction of the magnetic field, then right hand thumb rule says that we have to place our finger about that wire, we have to place our thumb about that wire, and we have to hold that wire by curling our other four fingers, okay. जो हमारी बाकी के चार उंगलियां हैं उनको हम कर्ल करके we will be holding this wire like that, and the thumb will be pointing along the wire like that, okay. For example, if I am having this duster and if I consider this duster to be in a form of a wire, so according to right hand thumb rule, the current is passing through this duster and I have to hold it like this, okay, like this by the four fingers, and the thumb will be in the form of straight way like that will be along that duster only, that is our wire. So this thumb will point the direction of current, okay. If the current is going upside, then this thumb will be pointing the direction of the current, and these curled finger will be giving the direction of magnetic field. So if current is going in the upside direction, so we place the thumb in the upside direction and we hold the wire like this, and this curl will give the direction of magnetic field. That means we can say that in this case the magnetic field will be in the form of circular form, because by curling we make a circle. So there will be number of magnetic field lines like that. And what will be the direction? The direction will be like that, because the current is upside and it will be moving in the form of anti-clockwise. Okay, the direction will be anti-clockwise. You can see. This is the direction of magnetic field lines. in case when the current is upside. But what happened when the current become down? Now the curl is in some other direction. Now you can see that the curl of our finger is in the way of clockwise direction. Okay, it is in the way of clockwise direction. So now we can draw the figure like that, and we can represent the magnetic field curves like this. And what will be the direction of that curve? Okay, what will be the direction of the magnetic field line? It will be just opposite to that figure, and now it will be going like that. Sorry, like this. Okay, in clockwise direction. And here it will be anti-clockwise. So this is how we can calculate the direction of magnetic field by using which rule? Right hand thumb rule. Okay. So let this much be for this video. Next we will see afterwards.